A machine learning Django app is being added to the project, visualization project, and here we look at the visualization for a machine learning dataset. The dataset is the University of California Irvine Machine Learning Repositories Breast Cancer Wisconsin Diagnostic Dataset. This dataset has close to 569 entries, and each of the entry has 30 dimensions. The datasets for machine learning usually have a lot of dimensions, and visualizing that dataset helps with the machine learning process. Here we look at 3 parallel coordinate charts for each of those 10 dimensions from the list of 30. And from the visualization itself, we can see that some dimensions can help with the diagnosis more than some other dimensions. And the red lines that you see on the visualization are the malignant readings for the nuclei measurements, and the blue ones are the benign readings. So if we filter based on a visualization, if we filter based on radius and perimeter, we can see that there is a lot more mutual exclusion after applying these filters further down the dimensions. If we do concavity and concave points, we can see that the amount of mutual exclusion, or the number of benign cells, is cell readings is more when we have filtered on these dimensions. So when we compare this to the second chart, which is actually the standard error on the readings for each of the dimensions, we can see that it doesn't help that much, because most of the data that has been presented is there is too much overlap. And for the last chart, which is the diagnosis to worst readings, which is worst meaning it is the mean of the 3 largest measurements, we can see that again the radius, perimeter, concavity and concave points appear to have a lot of mutual exclusion between the malignant readings and the benign readings. So this is something that can be inferred from a visualization on a data set, and is an example of how a visualization can help with understanding which dimension has more predictive value. And notice that we are going by the dimensions one by one to see, to help us with the decision on whether the reading is malignant or benign. And we are using, we are looking at the output of the previous filter and applying it to the next one. And visualizing machine learning datasets like this can also, in addition to helping with understanding the dimensions, can also help with deciding which algorithms to use for doing the classification or the machine learning. Here we look at some out-of-bag data sets and apply them to classifiers. So which classifier would be more suitable for this kind of data? After we have looked at the visualization, would a SVC be good? Would a random forest classifier or a gradient boosting classifier, which one of these would be more useful? Or would we go with the nearest neighbor classifier? Nearest neighbor classifier is also a very good candidate for medical diagnosis datasets and social networking, finding similar user kind of datasets. So let's, from the visualization, we can see that either we can use the nearest neighbor classifier datasets when we are projecting these coordinates on an n-dimensional space. People who have similar dimensions would be classified together. or would be together in that n-dimensional space. So that kind of classifier would be applicable. So let's look at the actual machine learning results on an out-of-bag data set and compare it to the inferences from the visualization. So we applied random forest classifier, gradient boosting classifier, k-neighbors classifier, and SVC. As we can see that the random forest and forest-based classifiers have a better accuracy on an out-of-bag data set. This is a verified out-of-bag data set which was randomly taken out of the original data set, and the classifiers were trained on the remaining data set, and the out-of-bag data set was used to check the validity. And we can see that the k-neighbors classifier also performs reasonably well with 83% accuracy, and SVC does not do so well. So coming back to the dimensions, from the visualization we saw that some of the dimensions are we inferred that some of the dimensions could be of more predictive value. It doesn't have to be like that, but that's what the visualization tells us. And we have to keep in mind that none of these dimensions can help with a binary decision by itself. And the forest classifiers have a attribute which tells us about the weight of each of the dimensions after the classifier has been trained. So it will tell us what is the weight assigned to each dimension and what is the importance, which tells us the importance of that dimension for the classification. So when we look at the gradient boosting classifier, we can see that it relates well to the inferences from the visualization. We can see that perimeter is important, concave points is important, same for the worst measurement readings. And the readings in the middle chart, the second chart in the visualization, they don't have that much weights in the classification process. And if we look at the random forest classifier, the inferences from the visualization are more prominent. We can see that the radius has got a larger weight, perimeter, concavity, and concave points, and the corresponding ones on the third chart, which is the worst reading measurements, those also are of greater importance or greater predictive value. So we can see that the inferences from visualization are validated from the actual classifiers data. So visualizing the data set before applying machine learning algorithms does definitely help with the machine learning process.